Hello, everybody, and welcome to the Reuse Company webinars. You will be muted during the webinar, but if you have any questions or comments, you can use the questions section. The webinar will be recorded, and in a few days, we will send you the link to the recording. Today's topic is configuration management in SES Engineering Studio, from a tool-centric to a life cycle-wide approach. My name is Cecilia Karlsson, and I will be hosting today's webinar. I have Elias Josfi with me. He's a senior key account manager at the Reuse Company. This is the agenda for today. First, we'll have a short introduction to the Reuse Company and the speaker. Then we will have an introduction and the context of configuration management. Next, Elias will talk about holistic configuration management for complex systems. After that, we will see configuration management in SES Engineering Studio, and then we will see a demonstration. And finally, we will have some time for questions. Let's start with a few words about the Reuse Company. The Reuse Company is a tool vendor specialized in the application of reuse methods, semantic technologies, and artificial intelligence to improve the digitalization of the systems engineering lifecycle. We promote lifecycle management methodologies guided by reuse, based on a knowledge-centric approach, supporting the notion of an authoritative source of truth, offering connectivity to everything, unlimited interoperability, and providing full support to technical management as in ISO 15288. We are usually known in the market for our software tools for requirements engineering, RQA Quality Studio, RAT Authoring Tool, Traceability Studio, V&V Studio, and KM Knowledge Manager. Our newest product, the SES Engineering Studio, is a tool for systems lifecycle management. Today's presenter is Elias Josfi. He is a senior key account manager at the Reuse Company. He has a technical background in energy and mechanical engineering and has also been involved in research projects. Elias is also passionate about international projects and languages. So let's start then with the presentation. Hello, Elias.
Hello, and thank you, Cecilia, for the introduction. So, as you were mentioning, the topic of today's webinar is configuration management. So before I get into this this concept of life cycle-wide configuration management, let's start with a short contextualization of configuration management. So maybe most of you are already aware of this process that you're probably using in your day-to-day activities. Just to make sure we get on the same page and have the same understanding of the concepts. And this is where we'll be starting from to introduce this lifecycle-wide configuration management concept. So let's start with some definitions coming from broadly used standards, like for example the ISO 15288, which is the basis for the concepts developed in the INCOSE guide, in the INCOSE Systems Engineering Handbook, sorry. And if you look at the definition, you see that you have the mention of the life cycle. Of course, the standard is related to life cycle processes, so everything is spinning around this concept of life cycle. And you have also the concept of consistency between the different product configurations throughout the life cycle. And if you look at another definition, coming from the EIA 649, you also see these two concepts of consistency and the fact that you have to produce and manage configurations throughout the life cycle. So this is just for the introduction of the concept. So configuration management is applied throughout the life cycle and is maintaining the integrity of configuration or consistency. But when you look at the concept here, at the process of the configuration management in the INCO Systems Engineering Handbook, you can see that we have concatenated configuration items, which are items designated by the system engineers or project managers at any stage of the life cycle, and which produce the baselines of the system configurations. So we maintain information about the product configuration throughout the life cycle to control the changes. So this is a concept that we are already using in system engineering activities, but this concept is described as an upon request task. So you can do it whenever you want throughout the life cycle, but it's something that is upon request. And we will see that one thing we have to deal with is change, and we will see in the lifecycle wide approach what happens when a change is brought is operated on the system, and what are the consequences on the whole lifecycle. So not considering only the object-centric or document-centric approach, but looking at the lifecycle. Before that, let's introduce the concept of change. So it's basically something that we cannot avoid, that's happening in any project, or that we should count with, because it has always a likelihood of happening. And if you look at this this diagram or graph here, you see that when you start from your original requests, requirements, or products, then the final delivery always includes changes, new requirements, or new items, changed requirements, deleted requirements. So we always like the Control Z feature. So whenever there's something we do that is not appropriate or not meeting the objective, then when you type something, it's easy as doing Control Z. When we talk about complex processes, that's not that easy. So what we would like to do is be able to go backwards before the consequences of change occur. So that's one of the main aspects here. It's to mitigate the risk of change and anticipate the risk of change. So when we talk about new requirements, we have to think, are these requirements necessary? So am I over specifying the specification? When we talk about changed requirements, whenever you change something to the existing specification, you have to think, are you introducing any conflicts? And of course, when you delete requirements, you have the opposite problem, which is that you might under-specify the system. So this required specification for final delivery shall also take into account these aspects. So basically, the summary of that is that you have to be careful with changes and requirements. So both mixed together is something that is very critical, because requirements, as often introduced, is the stage where most of the defects are introduced in throughout the life cycle, and changes make it difficult to control. So both together are producing failure in projects. So this is the project failure factors coming from the chaos report from the Standish group, and you see that the topics related to change and evolution of the requirements here produce more than 1/5 of the project failure factors. So you see, for example, changing requirements and incomplete requirements, which is something that could happen because of what I just told before. So the way the requirements are being created, edited, and deleted, and you see that all summed together is more than 1/5 of the project failure factors. So that's not something to neglect, of course, and that is something that you already know. And of course, we know these concepts and we apply them. But even though we apply these concepts and control appropriately the impacts of change, convert the threats from change into opportunities. So instead of having changes out of surprise, so not anticipating them, we can predict somehow, or at least mitigate the risks of change. And as I said, in complex systems, changes are complex to monitor. So the system development is complex. So all the activities are complex. It's not just a one-to-one relationship. It's not sequential. It's not something that is easy to monitor. One change can have an impact on many different things, and this is where the concept of lifecycle level configuration management will be important. So how do we measure the impact of change when we work at lifecycle level? So there's also an interaction with decision and risk management. So if you look at activities and decisions, why am I representing this here? It's because we have like a round trip process between activities and decisions. So one activity leads to a decision that the system engineering team, project management team has to make, and one decision has an impact on one or several activities, because whenever you get to a decision gate, you're kind of triggering the start of a new activity or other activities that are enabling this activity. So you are familiar with the concepts of enabling processes. So one activity is always performed with other activities that are supporting the system engineering lifecycle. So, and this decision, when it comes to the time when we have to take this decision, is in bringing a risk here, because depending on the choice we make, we introduce potential threats to the system. So instead of introducing these threats, we want these to be opportunities. For example, the change in the standard, or a change in the market here would be considered a threat. But if we take into account the impact, we can turn this into an opportunity. So basically, to sum up, one change in an activity can impact several decisions. One decision might impact several activities. So we always have this relationship that is not like an endless loop, because the idea is to have a from cradle to grave life cycle, which has dedicated time. But this is a round trip that is performed many times during the life cycle. So that's basically a need for a holistic approach, because we cannot consider only that one activity leads to one decision and one decision leads to the next activity. If it were that simple, then configuration management, as we think about it, as we have been thinking about it for many times, would be enough. So here is where I introduce the concept of configuration management process levels. So the first level is the one that we're mostly aware of. So when we change something at object level, by object, I consider a requirement, a model element, a simulation task, a test case. So anything, a risk, anything that is individual, that is elementary, is something that I consider an object. So throughout the life cycles, objects can be of many kinds, but all the objects have somehow attributes. The main example we know about attributes is, of course, the requirements. So when we change something in a requirement, we look at change by considering the attributes. See, if there's one of the attributes that has been changed, then we consider there's a change in the object. We generate a new version, and then we can compare versions, revert to previous versions. So all the tasks that we're expecting from change management and configuration management are related to attributes. So just changing the description of the requirement, changing the one of the attributes to priority, the applicability of the requirement, and so on. So this is for the object level. So basically represented here in a document and in a model here. And then you have the object set level. So the object set here, same as for the objects, it's a generic term or concept to designate a group of objects that is contained in a document, in a model, in a project charter. If we talk about goals and objectives defined in the statement of work, for example, so all the objects that you might find throughout the life cycle. And in this case, in order to manage changes in the objects, we will look how many objects have been changed, and in these objects, of course, how many attributes have been updated. So that's the second level. And then we have the lifecycle level, which is the one that we are dealing with, which is considered a necessary approach in complex systems. So if you look at the representation here, if we look at the V model is recursed in lower level V models also. So it's a complex system consisting of system elements that might be also systems that have their own life cycle. So whenever you change something in one document, it could impact changes at different stages of the life cycle, impact other stages of other life cycles. So how do we deal with that? So we're outside this box here. So how do we deal with that? So that's the main question. And if we look at some other example, if we look at let's say 2D view of the V model, so we transit from process to process to build the system, to develop the system, and you see that in each of the processes we produce documentation, specification, and some of the main productions are being baselined. So we keep a version of these elements. So configuration management is basically the process of applying this baselining at key stages of the life cycle. So when we do that, we keep track of the configuration of the product, and therefore we're capable of controlling the change that might occur in this document. But what about the interactions between these documents? What if I change something within the document? So that's the easiest example, because that's something that we all know. We change something in the document, we track the version changes within the document at object level, or if we want to check at document level, how many objects have been changed. That's something that most of the requirements management tools are already featuring, and mostly we're mostly using when working on specifications. So performing requirements engineering, for example, at document level is something we already know, we control. We go from the definition of the requirements to the inspection, and we have the management that is supporting all the activity. But then when it comes to changing in complex systems, we have iterative processes. So that means that somehow when we change the version of the document here, version 3 might impact another specification, which might itself impact another one. Because if I change, if the change in this document here at the architecture definition level impacts stakeholder requirements, we might have to come back to the business specification to validate if it's still meeting the customer objectives or the user objectives, and we have a loop. So the idea here is to be efficient and find out where the impact is being produced. So that's an example of iterative processes. And the other complexity introduced in complex systems in system engineering is the concept of recursion, which means that system elements might also undergo the same process. So I have a version 2 of a lower level element, which is impacting my main element in the architecture, which will be impacting the stakeholder requirements, and so on, or not. It could impact only this one and not this one. So we have to know when it will be impacting and when it will not be impacting. So the impact of change is not thinking that everything is going to be impacted, otherwise it's chaos, because you get frozen fear frozen, and say, oh, everything is going to change, so what am I going to do? Or you just know exactly where it's going to be. impacting. So we need indicators to specify what is going to change. So that's basically the idea. And then if we look at these change indicators, basically the idea is to know what decision will be impacted by change in the activity and what activity will be impacted by the decision. If we come back to this round trip between these two concepts, and if we look at the indicators here, we think about them as KPIs because they're change indicators of the life cycle, and at the same time they indicate how far am I finding myself in the life cycle process. So that means that checking traceability, verification, validation indicators, and quality indicators, I might know, for example, how many untraced requirements I have. If I'm still fulfilling system requirements or fulfilling stakeholder needs, after changing one element, that might impact, as I said, many other elements in different stages. And also, are the requirements models specified properly? If we talk about quality, so quality assurance, if I have a standard that specifies how, or I have to specify the requirements. In that case, we would look at standards like the ISO 29148. I have to check if once this change is going to impact also the quality assurance. So I'm not only checking the completeness of the specification. If I have a missing requirement that is makes the specification under-specify the system, I'm also checking if it's specified using the correct syntax, and also if all these elements are traced. So it's a combination of indicators that help in the decision throughout the life cycle. So some indicators that we have here are the rate of high, medium, low quality work products. So here, work products is like the objects, the generic word I use for the items, the engineering items we produce throughout the life cycle. That will be configuration items, mostly when involved in these decisions and key activities. We have the attributes specified. So this might be also a quality indicator. So I might have a high quality work product in terms of syntax, it's well written, but I'm missing an attribute, or I'm missing a property. So something is missing in the item. The same for the traceability. We have missing traces, so the so-called orphan requirements or items or objects. We have suspect links. So if there's a change on one side of the traceability link, the other side should be targeted as a suspect link, which means that this traceability might be threatened by the change. So we have to know if this is going to remain. If it doesn't remain, then the percentage of missing traces is increasing, and then we have to find the traceability to avoid the orphans. So indicators are combined together, and within one of the aspects covered by the indicators, we also have some links. Also, how many elements have been traced manually and automatically, suggested by algorithms, for example, and also the traceability matrix, which is one of the elements that we produce when specifying the system. And finally, the VMV indicators, so how many elements have been verified or not verified. So let's say the things that these three indicators have in common, and that's why they're very useful for the configuration management at lifecycle level. The three things that they have in common is that they can be applied at any stage in the lifecycle. So we can perform verification, validation early in the lifecycle. We can perform it anytime after. Same for the quality assurance. We can apply quality assurance, quality control anytime throughout the life cycle, and the traceability, of course, of all the objects produced throughout the life cycle. And these not only are indicators of change, but also activity progress indicators. So we know by looking into these indicators, if they change, it means that something has changed in one of the elements throughout the life cycle, but also it tells us if we are completing or not the specification or the stage in the life cycle. So having said all this here, let's introduce the concept of configuration management environment. So we already looked at some aspects of that, zooming in on the object and the object set levels. But before thinking about doing configuration management, of course, as suggested by the INCOSE guide, the INCOSE System Engineering Handbook, we have to start with the support of a knowledge management system and an information management system. So these changes that we detect, the configurations that we produce, they have to be stored somewhere. So they are knowledge and information assets that will be sharing, that will be monitoring and using throughout the life cycle. So we need to have a synchronized source of truth that is going to help us first store this information, and this stored information will help us detect other changes. So it's like self-feeding throughout the life cycle, and we need this to be a synchronized source of truth, because as we are developing complex systems, we use many different tools, many different languages. So I'm not only talking about natural language and the speaking language of the humans, but also modeling languages, programming languages. So this information, it could be of various kinds or various natures, but it should be synchronized so that we maintain the integrity. So we cannot perform configuration management in a consistent way if the information we base ourselves on is not consistent. So that's the first stage we need to have. Then when we have a knowledge management system, which is enabling the processes of the lifecycle to happen in a consistent way, then we can start the first level, which is the object level configuration management, which is checking the attributes. What we introduce here is the concept of version, the version of an object. When we go at object set level, so object set is the let's say the standard word, let's say let's say the common word I use for work product set, documents, models, anything, as I said in the beginning. And this object set is producing a baseline consisting of different objects that undergo or not undergo, that don't undergo changes. And then in order to move to the lifecycle level, we need to introduce the quality indicators, quality, traceability, and VMV. And once we have these elements defined, then we can build up the lifecycle-wide configuration management. And one version of the lifecycle-wide configuration is what we call the global configuration or just configuration, considering that the other names are different. So we have versions impact baselines, and the changing baselines based on these indicators provide different configurations throughout the life cycle. So if we look at quality, one example would be a change in internal procedures or standards regulation that might affect the assessment results, and therefore decisions at the life cycle. So as always, the results impact decisions impact other activities. So that means we don't change the quality, we don't change the object description, but the way it is assessed produces a change. So it's not just checking if one user modified the requirement or the model, but it's also with the same element that I have. We will see an example in the video, one of the demo video that I have at the end, one of the video clips. So sometimes you don't produce change, but the attributes, the indicators that characterize the life cycle is changing. One of these indicators changes, so you have to detect that as a change, even though the objects are not changing. They're impacting change in other objects. Same for traceability. If I delete one element from one document, all the other documents are the same. But the fact that I deleted this element produces a change in the traceability. Maybe in the other documents, I have some orphan requirements because they were linked to this item that I deleted. So I have to make sure I maintain 100% traceability between the work products at all stages and avoid orphans. And finally, the VMV here. If I change system requirement, it will impact the verification actions. And if I change the stakeholder needs, remember the first slide with the V cycle and the iterative processes. So I should have a change at architecture definition level, which might impact stakeholder needs and requirements, and this could affect in the end the business and mission analysis. So if I change something then that impacts system requirements or stakeholder needs, I might also impact the verification and validation actions. So I need to produce new verification, updated verification and validation actions, and these updated actions will also produce other results, because if I verify with one stakeholder need or requirement or validate, then if I change these objects, the reference, the source item is different, so I have to update the result. So and this produces impacts in the life cycle. So one example would be to change one work product. So I change the work product, so I act on the work product. It will affect the attributes, and by affecting one of the objects in the object set, it will affect the object, the document or model, and we could produce a new baseline after the change. So by changing the object, so when we stay at object set level, that's it. We changed one element. This element affects one object set, and that's it. But what about the other documents? So here, if I change one object, it might affect also the quality assessment of that object. So let's say a model-based MBSC object, like an object in the diagram, or state transition, or the consistency of the state machine. Then it might affect the quality of this object, and the quality as an indicator will produce an updated configuration, because the fact that the quality is changing might affect also other objects, because if I trace one for example, one system requirement to a stakeholder need that has a low quality, then this also is to be reported, because I cannot trace to objects that are not rated as high as I'm expecting. And then the quality might affect, of course, the baseline, because I'm changing the quality attributes of this baseline, the traceability of many other objects found in different object sets, each of them with a previous baseline that has been produced, and also VMV actions. In the second example, that's even more interesting, because we're not changing the object. We're just changing the quality assurance methodology, changing the way we assess the objects. So when I said we need to have a knowledge management system, this information would be communicated, would be spread throughout the teams and the organization by the knowledge management system. So the fact that I changed, there's a change in the standards that might affect the way we assess the objects, is coming from this synchronized source of truth, which is affecting the quality of the overall configuration. And the configuration is consisting of different baselines, so the quality of all the objects will be assessed again, which is changing one object attribute, in this case the quality, and this object change is producing a new configuration. So you see that the information is being related in terms of indicators. So the indicators here are enabling the transition between the document-centric and the lifecycle-wide approach. So if we look at the approach in SES Engineering Studio, so we already presented this new multi-activity platform in other webinars, but I'm just going to recap a little bit what this platform is doing. So it consists of a set of core capabilities to enable the connectivity to various sources. So if we want to perform this system lifecycle management within this platform, we need to be able to connect to different sources, models, so logical modeling, physical modeling, textual information, and anything that we might think of, simulation, 3D simulation, so anything. And this enables to perform the lifecycle management. So defining the activities, the way they're performed, the decision gates, and so on. Of course, we have the change, configuration, and version management, which is available to help in this lifecycle-wide configuration management and the lifecycle activity management in general. And we have also another set of features that help feeding information for the lifecycle. So how we can bind elements from different connections with the interoperability. So we already presented these in other webinars. If you're interested, you can check the webinars section. We will recap the link at the end of the webinar if you're interested. So traceability is one of the aspects. It's belonging to the core capabilities. And we also have the VMV and quality management capabilities that are available as additional capabilities. So they're embedded within SES Engineering Studio, but they are additional components that you can add on top of them. But they're all within the same tool. So if we put this tool in the context of the lifecycle, as I said, it's a multi-capability platform, which is helping us perform activities across the system lifecycle. And it's consisting mainly in connecting to different sources and gathering, synchronizing the information from different sources in our knowledge repository, which is storing the information, the assets, so the knowledge information and the assets produced by the system development. So all the versions, all the baselines, the configurations that we previously mentioned, the information of the quality, traceability, VMV, and the impact it has on other activities is stored. And this is what is helping us doing the assessment of the lifecycle progress. And it's the main tool of the Systems Engineering Suite, which is composed of other supporting tools that mainly help us design and develop the knowledge management here, the knowledge base, and another set of tools to complete the process. So speaking of configuration management, if we look at configuration management at object level, it's already defined, as I said at the beginning, in some ISO standards. So we basically apply the standard to the scope of one work product. So in this case, we have versions generated. Sometimes it's automatically generated. So at object level, the difference with the other levels is that at object level, we can perform some automatic changes. So given the fact that we change many objects during the life cycle, it would be very tedious to have the user produce versions and request for versions anytime he or she is changing the object. So in some cases, the versions are produced automatically. When we have unsaved changes that are saved by the user, then this is producing a version, because otherwise I would have to create a version for all the objects or create a version for the object set. But since we save, this is already created, and the versions generated also impact the object set. Same if we include a raw product within the traceability. If I create a trace, I'm producing a change at object level and therefore at object set level. So in order to avoid having to create a version at this moment, when we create a trace within the SES Engineering Studio, we also produce a version, which is going to be checked whenever we have to look for suspect links. This is one of the examples I was showing in the video, and this way we manage changes. And we have also manual change versions, so whenever it's requested by the user, and in the lifecycle management at lifecycle level when we create a configuration. And of course, we can perform reverts and different details aspects in in this case. So here it's just representing the fact that at date 1 we first save and it's creating a version, the current one which is kept. Then another save is creating another version, and the other one is still remembered, and we can revert to this one. And finally, we have a version created when we decide to do it manually, and then it will be creating another versions and so on and so forth. At project level, we can check, for example, the baselines locally for one document, and this document is one of the is the main element, which is consisting of many different sub-elements that are also versioned within the process. So if we look at lifecycle configuration, here I'm not talking about the indicators. Let's imagine that some of the indicators change here. What I'm interested in is the lifecycle approach. So if I have a set of subsystems here, we can see, for example, that here we have a first global configuration, which is consisting of versions of the different baselines. And whenever there's a new baseline that is generated because one thing is changed, so the version 1.2 here could be generated even though we don't have any change in the objects. It could be generated because the traceability from this baseline, this document, to other elements here has changed, because we might have deleted here these elements, or we might have produced a trace between the screen and the cooling system to indicate that the system is below the accepted temperature, and so on. So this is producing in the end a new configuration at global level, at lifecycle level. We will see an example in the demo. And here we have an example of the lifecycle configuration. So we check the differences at lifecycle level. We check the sequence of activity, and we compare it with the progress. And so that's why I mentioned also the concept of progress indicator, not only change indicator, but both are related, because we use this as a progress indicator, and we compare this to previous configurations to see what changed. And we'll see an example in the demo that is just coming right now. So let's look at the first use case. The first use case is here the use of configuration management at object level. So in this case, we're just looking at configuration management without talking about we talk about change requests, how we manage change requests, which is also an important factor we have to manage. So in this case, I'm not considering change requests. I will do it in the second use case. I'm just performing changes, and I will check how the tool is monitoring and showing the differences between the objects. So first step is to create a baseline of the document. Here I'm working with an Excel sheet. So remember that we can connect to different sources, and whenever we connect to a source, the view we have in the content is the one we have here. So we perform here changes on different elements. So you see that the status is becoming updated on the repository and in the source. So it's pending save, and whenever it's saved, it will be propagated within the repository, saving the assets within our internal repository and also saving it in the source. And then we can see the versions for one individual element, see what changed. Basically here the markup of the changes, and below the attributes that have been changed apart from the description, of course, which is displayed here. So description has changed, and therefore the status, the date of modification and the time of modification has changed. Then if we look at baseline differences, it's the upper level. So it's consisting of seeing the change in the baselines, which is comparing the change in the objects. So if I look at the current version, I could look at previous versions here, or considering the current one and compare it with the first one, which was produced at the beginning of the project. So here we see that we have three changes, the ones that we just performed. And if we check a little bit the view, we have here the changed here of values. We have 80 centimeters here, and then we click here, the view is synchronized. you click on one side, it's showing the other objects on the other side. And when you click on view changes, you can see individually the change. So here we have version 2 for this object, whereas the other object could be of version 5. So each object has its own versioning life, and it's all compiled within the baseline. This is something that you already have experienced in other occasions. So now we will be introducing another aspect, which is change control. So then, in order to enable change control, we rely on user levels and user permissions. So here I will be introducing the concept of change control board. So one of my users here is an administrator and has the ability to enable this change request or disable this change request mode. And whenever it's enabled, you see that now it's featured in gray, and you only can perform changes under the change request mode and start changing the request and then saving these requests. So you see that I'm an administrator here. If I exit the tool and disconnect, it's like a log out basically. The next time I'm connecting to the same repository in which I'm performing the lifecycle activities, I will be showing the example with a different user. So I configure the user. Instead of using the administrator user, I'm using my Windows user, which I gave a different permissions to this particular document. So when I open the repository, you see that I'm connected as my named user, not the administrator, and you'll see that within this multi-activity platform that System Engineering Studio is featuring, we can also manage permissions. So if I decide to get rid of the change request, you see that I cannot perform anything. I'm not allowed to do so. So I don't have any choice but to work within the change request mode. So whenever I start the change request, you see that now the tool is enabling the changes. So you see that it's not great anymore. And seeing that, you can start modify the elements. So you could decide to change, for example, the temperature range in the inactive mode here, and change as well the time duration of the project, or the total development period here, 14 months, and then maybe the maximum temperature registered here. Instead of 40 degrees, we can put 50, and then also change the minimum temperature. So we see that it's updated. It means that it's updated compared with the current version in the source and in the repository. And then when we provide the change request here, we send the change request, and then it becomes again gray and read-only. So now I will connect as one of the members of the change control board. I called this member Joe Manager, basically, and he's member of the change control board and has credentials and permissions to execute the change request approval. So it's basically gathering together all the concept of change proposals, change requests, engineering notices that we have in the configuration management process. And you see that here we have another user, Joe Manager, and this user, Joe Manager, is opening the same document. And we have here in the change management on the top. So just as a recap, everything that is on the top is what is repository wide. So we create change requests within one document, but the change management, the approval of the change request, can happen in many different documents. So the list of modules here can be very long. So that's why it's not featured within one connection. It's something you can access from the top of the window. So here I can manage the pending change requests. It's the change request set that I sent with the username you see before. And when you click on manage changes, you see the different elements that have been changed. And then if you want to check what changed, you can manage resolution, and it shows the elements that has changed. So you see the markup again, and below you see the attributes, internal meta model we have to cope with the attributes. So it's not showing all of them. We can only show the one that changed, and then we can decide to do the resolution status. So approve this one, and then we can say reject all the pending. So it's only accepting age 28. So then we save the change request details and resolution, and then the status of the change request is now solved, which means that I performed I approved the changes only for one requirement, and then when I exit the change request mode, now I'm manager, so I can do it, and I can keep working on the versioning, so creating a new baseline or version for at object level. And if we look at the objects here, we can see that this has not changed because it was not approved. And we can also check the versions at object level, see what happened. The fact that I saved created a new version of the objects, so I can check the current with the previous one that was generated before the change request mode. And we will see that, of course, I didn't save the baseline of the other objects. You see that it's not the version at object set level, at baseline level is not automatic. And you see that the only one that has been added to these three changes after that was the first of the 4 requirements under change request. And then we can, of course, create a baseline with the newest information. So the name is up to you. The tool is automatically generating the version number, but then you can create the baseline with the name you decide. And then we can also see another aspect of change management is, of course, we're talking about changes that happen within SES Engineering Studio. But what about what happens outside of the document? So I could have changes within SES Engineering Studio, but what happens if at the same time or at different moments of time, some of the changes are performed in the source? Remember that I'm connecting the SES Engineering Studio, I'm managing the changes within the repository and comparing versions stored as assets in the repository, but what happens if I change something outside? So here, I change one requirement, SH06, and add the operation parameters. So if I open the element here, the connection, you will see that the status will also be featured. So remember before that you had the color of the updated version of the updated state on both this column and this one, because whenever there's a change performed from SES Engineering Studio, you also are pending a change in the source. But now that it's coming from the source is in loaded mode, so nothing has to be saved, but the repository is still not updated with this change. And therefore, we can also compare the repository status with the source. There's a function called view changes with the source. And you see here that we will show the repository on the left side, source on the right side, and you see that we added end operation. So you manage also changes and you control changes between source and repository, which is our internal knowledge base. And then, of course, you can create another baseline and show the differences. So again, we saw it many times. I'm going to move to the last use case, which is the lifecycle-wide approach. So now I created different connections. I have different activities, as I showed in the presentation, that are showing part of the life cycle here. And what I'm going to do is change one requirement here in the system requirements that come from the doors project. and I will be showing the impact throughout the life cycle. So of course, here I'm going to link using traceability. I'm going to link one requirement talking about the sensor component. And here, so I have another element that has been selected, so I can remove the trace. And I can keep only the one that is of interest, which is here the source and the target. So we have the sensor, and the sensor component shall be 1.4 watt. So if I go to the doors requirement, I can change it here. So within the different connections, I can sort a little bit the windows. I can, of course, I can maximize this and make it a floating window that can be put in another screen. So the view, the way it is featured is up to the user. So here I'm going to change the element. I'm not calling it sensor component. I'm just calling it sensor. So what happens if I do that? The first thing is that I'm updating an object indoors. So obviously, by saving, I'm saving a version of the object, and therefore the current version of the document is different from the last one in the configuration, because here I'm working at lifecycle level. But that's not the only change, because since I traced these elements, if I evaluate suspect links, now it's going to produce a suspect link between the requirement indoors and the model element in Capella. And you see that the trace is suspect link created by Job Manager, which was the last user here. And you see that the version is updated and is shown in the traceability module. So now that we did that, we can evaluate throughout the life cycle what is the overall impact. So, and we will see what's happening. So I'm evaluating all the activities and all the changes made in the different elements. So in the quality of the requirements and in the traceability. I think I didn't include the evaluation of the verification and validation at this moment. And you see that now we have suspect traces detected at different levels. So the ones that have been impacted by the change I performed. And then if we move, we can create a configuration of this. So the change indicators are there. So the one change is in the document level and object level, of course, and the other change is at lifecycle level because the indicators of traceability changed. And we will have a look at the version of the different documents or assets here. It's very important. So I mentioned that even though you don't change the content, the description of the elements, we might produce a new version because one of the indicators changed. And that's what we will see in the project configuration view. So it's creating the whole configuration. Let's move on so that I can show you the project configuration. So you see the traceability, the completeness, how many elements have been traced, and so on. So they're all traced, but some of them are suspects. So there are two independent indicators. And then when we view the configurations, we can check the differences. And here, if we look at the last baseline that has been generated, we see that we have, we organize here the columns as well. Just take a look at the versions. That's very important. So I will use the pointer here. The document endorsed was version 4. It moved to version 5 because of the version of the object, which was version 3 and moved to version 4. So object versions are different from the baseline version. So again, and the Capella model didn't change, but the traceability status of one of the objects changed. So it's creating a new version here. You see that it's version 4. It was version 3. So that is how we can control the changes based on the life cycle. And if we look at if we compare the differences in the doors document, of course, we will see here the updated element. So it's SES 179. I'm going to move on to you see that the elements have changed. We can do the same as we do within the connection, which is to check the markups. And the other thing we can do is compare the Capella model. And you can see that if we look at only the descriptions, nothing changed. Version 4 and version 3 are the same, but what changes is the traceability. So that's an example, let's say pretty elementary, but just for you to get the notion of lifecycle-wide configuration management in SES Studio. And the most important thing is the link between the indicators of the activities and the versioning of the individual connections and documents. So now let's see if we have some questions in the audience.
Thank you, Elias, for your presentation. Elias will answer your questions in a minute. So if you want to ask him anything, please write down your questions in the questions section. Meanwhile, I will talk about next webinar. It's called Controlling the Values of Your Signals in Technical Specifications, How to Connect Your Requirements Management Tool to a Project Dictionary. Have you ever dealt with low-level specifications involving signals and messages? How to know the exact name of the signals and their possible values requires a project dictionary that in most cases is far away from the requirements management tool. In this 15-minute webinar, you will learn how the SES Engineering Studio tackles this issue by connecting your preferred requirements management tool to a project dictionary in real time, suggesting the right names, checking the range of the expected values, checking which signals can be sent or received by the components described in your textual requirements, and all this quickly and simply. The dates for this webinar are the 13th and 15th of December. So over to the questions. Okay, is it required to assess all the aspects of quality, traceability, and V&V to detect changes, or can it be a partial analysis?
So I basically here in this case, in the example I mentioned, we did assess only the correctness, completeness, consistency, and the traceability assessment. So we can unselect some of the activities we have to perform to detect the changes. So I can maybe show you an example here. So if I go to the sharing the screen, so I will just share the screen. Now you should see my screen with the application. So in this case, when you assess the life cycle and you change indicators here, you can also update the way you will be assessing the technical management. By technical management, we understand the three indicators: quality, verification and validation, and traceability. And as you can see here, verification and validation is not enabled. So depending on the lifecycle configuration management you would like to perform, you can decide to include or not these aspects. So it's something that you can set up in the tool. In any case, once you perform the assessment, you can see the changes as I mentioned and create the versions. So, and you can always perform a new feature after. So I hope it answers the question.
You have focused your demo on textual requirements, but what about models? Can you control changes and generate baselines within models like Rhapsody, Capella, or Cameo?
Okay, so that's a good point as well. So of course, the first use cases I showed as showed in this webinar, were featuring the Excel sheet I was connecting to. So we had the stakeholder requirements connected. But as I mentioned while introducing SES Engineering Studio as a connectivity workbench, you see that in the end, all the assets we connect to have the same aspect. So if we connect to a Capella model, if we decide to not to import the full Capella model, but just to have the list of elements featured in Capella with the, so here in the view, we can include the type, if it's a state, a requirement, etc. And on these elements coming from the Capella file, the .arrd file, if you consider the elements of the diagram, we can do the same as we did in Excel, which is configuration management at baseline level or just at object level, creating versions. So versions at object level, baseline at document level or model level in this case, and then this is embedded within the life cycle as shown in the third use case.
Okay, thank you very much, Elias. Let's finish here. Thank you very much, everybody, for attending. If you have additional questions or want more information about our tools, don't hesitate to contact us by email directly to Elias or to contact@reuscompany.com. You can also find information on our website, reuscompany.com, and videos from previous webinars, etc., on our YouTube channel. Thank you very much and goodbye.
Thank you. Bye, everyone. Have a nice day.